Well, hi, good morning, and thank you so much for joining me in my shop here. It's August 20th. Believe it or not, it's 11 degrees outside when I got up this morning. That's kind of fall temperatures here. Even though it's late August, it should be pretty hot. It's only 13 outside now. Man, that's cold. So, what about this radio? Well, the first video I shot, video number one, I didn't know much about this radio. I just knew it was something. I really didn't know much at all about it. But since then, I've done many hours of reading up, and thank you to those who have put the time and effort out to make really nice websites full of interesting information about this particular model of radio. So now my head is full of interesting facts, but I'm going to tell you the most interesting fact about this particular radio, this one here, are these three outputs here. There you can see it says phones, line, and underneath here it says 2000 ohms, 500 ohm monitor, and 500 ohms here. This change, the addition of these, actually on most of these radios there's one here. Some of the later ones there's a knob here for adjusting something. I'm not sure what it is, but on none of them will you find this arrangement, except on those that were bought by the Canadian Army to be used in their signal corps back in World War II. They purchased supposedly around 200 of these, and they made this modification to them. This is probably a later one of them, because there was certainly a time, I've seen photographs, where the Canadian Army had fixed labels here where you see these words. They had fixed large screwed-on labels on here, but there's no such thing on this one. So I've learned an awful lot about this, and I'm not going to sit here and try to recant it, because I can't recant it. But it'll come out as we work along on this radio, checking it out more and more thoroughly. So one of the things is, where is the serial number on this unit? Now, I'm wearing new glasses today, so I can finally see again. I can see again. See that number right there? 0494. That number also appears right on the set of coils here, right where I'm pointing. And it appears in one more place that I found so far, and that's right up on this shield. The shield is also something which was additional for the Canadian model, I believe. I think I read that. 0494. So each of these radios comes with a serial number with a letter in it, and the letter indicated which production run it was. The production runs were running around 250 units, something like that. So there's an A radio, A1 to A200, 300, 400, something like that. A B, a C, a D, E, F, and so on. But I can't find that on this radio. Now, the normal place for the serial number to be placed is right down in there, not scratched, but put on the chassis, right in front of the antenna terminals. As you can kind of see that I'm pointing right at the antenna terminals. But this radio has been altered, and this has been added to it. It's a very professional job. It's not done by an amateur. Probably done it could even have been done in the national factory as an order from the Canadian government. Normally there's just two binding posts there, and there's a window here. There's just an opening. The thing about the opening is you can look in and see the serial number, which is written right down in there. Now it's a little hard to see in the dark here. I'm going to get a little more light in there. There's two antenna terminals down there. You can see them. And those are the antenna terminals for the radio itself, and then they're attached to a balun in there, which is then attached, to this. So this, I'm pretty sure, was a Canadian Army edition. No doubt their systems are using this PL259 style connectors, and they wanted that on the radio. So that means this is a really important radio to me, because it clearly has been part of the Canadian Army. That's why it's here in Canada, I'm sure. So somewhere there's another couple hundred of these floating around. How many of them have survived to today? Goodness knows. My understanding is there's something like 60 to 80,000 of these radios made over a long period of time, about 25 years, maybe even longer, 30 years. Basically the same radio being made. So there's bound to be quite a few of these floating around. These units here, which pull out. So this is the band coils here. These are specific to a certain radio. Look at that. I didn't notice that before. 230L. I didn't notice that. How could I not have noticed that? Look at this thing. Oh my gosh. Oh, I know. I have two radios, and it's the other one. I pulled the unit out of it and inspected carefully. Maybe I didn't do it with this one. 70 to 14.4. That's the band range. And so put it on both sides here. It says, OK, C. Inspector C must have taken a look at this. Supposedly, these, there's some stuff in here. These, although you can shove them into another model, like another radio, and the radio will probably work. These have almost certainly been tuned up for this radio. So you really try to keep the same set of coils with the same radio, and that's why this one has the number there, 0494 and 0494. Make it really hard to make a mistake. Put the wrong coils in. Not that any damage would occur. Things just wouldn't work quite as well as they should. Now, my goal here is to power this radio up and get it working, even as it sits in front of us. Now, I've already looked underneath the panel. The last video we looked underneath, there was a bunch of many molded capacitors, and not particularly reliable. I think we can make a good assumption that they were using some of the best parts they could find at the time they built this. Is what I was seeing under there? Are those replacement parts? I don't think so. I think these are the Bumblebee type capacitors. I'm talking about capacitors because it's very likely a failed or many failed capacitors in here. Failed in the sense that they're leaky and they don't really represent the capacitance that they're supposed to. And in the worst case, there could be a short circuit in one of those capacitors. A short circuit like that, depending upon exactly which capacitor it is, could put at risk some of the parts in the radio. Some of these parts not, replaceable. I mean, it'd really be a big problem if you burned up a coil inside one of these things because of a shorted capacitor, because you were anxious to get this going, Jim. That would be the sad part of the story. I've gathered up enough information. I can sort out what is going on with this, what voltages and power should be supplied. It really boils down to, this is a 6 volt. This has 6 volt tubes in it, so you need a 6 volt AC supply. I'm going to guess right now it goes on these two fat pins. I'm not sure of that. And then you also need a high voltage supply, a couple hundred volts, a little more, a little less, and the radio should operate fine. And I've got a supply up here, a variable supply here, which I can use to supply the DC the radio is looking for. There's no power supply in the radio, and the reason for that is because the power supplies get hot, and that heat would slowly cast itself through the radio in whatever way it would, and during the heating up process the different component values begin to drift a little bit, and then the radio drifts. Well, this is supposed to be, a real top quality radio at the time. It can't have it drifting. So one way to avoid that was to put the hot parts outside of the radio, make the power supply a separate unit, sitting somewhere out here. I don't have that separate unit. Maybe I will someday, but not right now. So I got to power it from shop supplies. I think the first step would be to set up and apply the 6 volt heater voltage and turn these tubes on and see if that works. See if I can actually supply that power. My power supply up here actually has an output of 6.3 volts right here, maximum 4 amps. Well, this is pretty close to what this guy's gonna be looking for. So I maybe a little hesitant on that. And the next stage would be to apply the, I'm just rehearsing here, it would be to apply the high voltage using this guy again, and slowly bring it up. I can read the current draw on the radio. Now at full voltage, the current draw from the DC supply should be something like 70 milliamps. That's about halfway through the safe zone. You probably can't see it, but there's a red mark here saying danger. Don't operate continuously above this red mark. So it's going to be, so this radio, of course, is going to put a demand on that power supply. That may be the biggest demand that's felt. So there could be issues with the power supply too. It could be hummy, and the hum may come through speaker. That's right too. Have to solve the speaker thing. Now I mentioned these different outputs, and most of these radios have one output. And Danger Will Robinson, the B plus is present right on the terminal of the output in many cases. If we look at the schematic, we would see that in fact the speaker plays the role of the plate resistor in the output circuit, the output tube output circuit. So your options here are: get a very high impedance speaker like a 7,000 ohm speaker. I don't have anything like that. Yes, I do. I do have something like that, which we could play around with later. Or stay away from this output, or get a output transformer and connect it so it matches the impedance of a low impedance speaker or something like that. You know what I'm talking about. But I'm going to stay away from that. I don't like the idea of B plus. You know, you can plug headphones in here, then take the headphones and put them on your head with B plus going up to the headphones. It doesn't sound like a good idea to me. But I guess it saved them an output transformer. I don't know. But this one's been modified. Now it has another section here, and this one, where this one's taking the literally the plate current running through it, if you like. And I guess if you plug nothing in there, then that tube is shut off plate-wise. That raises an interesting question. It says 2,000 ohms there. This one says 500 ohm monitor. Is that another word for speaker? Monitor? And this one is a tap off the cathode circuit of, I believe, the output tube. I could be wrong about that. But this is the one we would be interested in, where it has the word line here and 500 ohms written underneath it. Apparently, this is connected to an output transformer, an additional transformer installed in the unit at the request of the Canadian Army, or by the Canadian Army. The output transformer, the thing I was reading, it mentioned it was a Hammond transformer. So Hammond was a big transformer manufacturer here in Ontario. Very well known, been around a long time, still making transformers. As far as I know, you can still order Hammond transformers recently built for old tube radios. I think you can do that. Don't quote me, but take a look at Hammond transformers on the internet if you want to know more about that. So supposedly this is already connected to an output transformer, so you could put a speaker in here, but again it's 500 ohms. So speaker, probably this is really intended to have headphones plugged into it. I don't know. I think the Canadian government wanted the B plus away from here. So maybe I've got the story wrong a little bit. Maybe even something was done here to make sure that B plus didn't come up into any of these connectors. Because boy, that just sounds like a dangerous thing to have. But an unmodified version of this radio, I believe that's the case. Now, let me change my story right away because I'm just remembering things. I read so much about this radio. Yeah, the headphones at the front take their power, get their power not from the output tube, but from the tube ahead of it, the triode amplifier tube. That's where the headphone jack is connected. Speakers. So now there's another additional thing going on here. There's two additional things going on here. So there's a jack here, which I don't think is a regular thing. I think this also is an addition by the Canadian Army. There's a wire coming out here which is cut off. I don't know what that is. I can't. Did I look at this when I had the bottom off? We're gonna have to look at this again. This could be a speaker wire coming from output transformer, a special one that was installed. I don't know. And then this jumper has to be in place, and I can't remember exactly where it is in the circuit, but I believe also there's high voltage here, and I could be wrong about that, but the radios with this jumper missing will not work. And these look like antenna terminals, they look like speaker terminals, and they're neither. So still some question marks about the output on this, and since this guy's been modified, I don't have any modified information. Oh my gosh! How did I miss this? There's a tag right here. We'll get a better camera and look at that. How did I miss that? Again, I've got two of these, and I've been looking at them alternately, and so I guess I've just kind of mixed myself up a bit. Okay, we'll flip to this camera, and we'll see what we can see here. Oops, wait a sec. The camera cord is caught on a piece of subway track. What? Yeah. Just give it a moment here to focus. So, hey, come on. There. The Royal Canadian Corps of Signals. That's what that says at the very top. Manufactured by the Royal Canadian Corps of Signals. Canadian Signals Experimental Equipment. Mod. No serial number. I was hoping to find a serial number there, but mod. They didn't put like a modification number 2 or anything. Just mod. Type number Canadian Signals Experimental Establishment. Canadian Signals Experimental Establishment. I think that's what that says. Yeah, establishment. The CSEE. Now I can't go into any details, but my son, who is in the reserves, is part of the Canadian Signals Establishment now. I don't think it's called that, but he's doing in the modern day, as a reservist, the kinds of things that were done with this old radio. Experimental. That's interesting. Experimental establishment. Never heard of it. Something more for me to look into. I mean, it does have this. Malden, Massachusetts. So it would look like they bought a couple hundred of these units and then alter them here in Canada at the establishment. That. So, if we look inside, and it's going to be way too dark, but so down there should be the serial number, but it'll be under that plate. I believe it's under the plate. So aside from this number, which is quite likely to be the serial number without the letter. Without the letter, it's pretty tough to figure out just when this was made. Somebody made a couple of notes here. Frequencies and the dial number. Scratched right in there. You notice this is a JB, coil set type JB. So it's a B, B, it means it's this range, and the J means it was made for military purposes. This side on some of these coil packs have, as I understand it, basically two sets of coils, or a way to operate the coil set, two ways to operate it, and one would be the regular way to do it, and then there was a band spread. So for instance, this one contains the well, it's got 7 megahertz and it's got 14 megahertz. Probably the 20 meter band would be over here. There'd be another graph just like this over here, and then you could alter this thing. You have to pull it out, do something with screws, and then it's working on this side, and it becomes a band spread radio for ham radio operators. But see, the military didn't care about the 20 meter ham band, so that disappeared. In its place, they just put this chart, and then this is in case you really haven't said this, but I will now. If you see up here, the number dial just has numbers. 60 if it focuses, 50, 40, so on and so forth. And yes, first time I looked at this, yes, I did look at it. I didn't go far enough to find out it goes 100. So it's 140. So that makes this 140, 141, 142, 143, 145, 130. See how that works? I see how it works. You take these numbers. The radio's tuned to 130. And you look down here, and you go 1. You get your eyes to focus. What an annoying thing this camera can be. So you find 130, you read up on the line, you come across, and look at the kind of accuracy. You couldn't get any kind of accuracy. So 130 will be something like 8.4 megahertz. No accuracy here, but huge accuracy on these numbers. Apparently, if you took this wheel and stretched the entire scale out, which I mean, there's no physical way of doing that, but if you were to imagine the scale, you know, how long is this? Apparently, it's 12 feet. Oh, hit the end there. 490. It's 12 feet. There's 12 feet of this. So that's like having a radio with a 12-foot wide band spread you're tuning on. That's pretty spread, I would say. Okay, I did look at replacing this knob. I have some similar ones here I brought in to look at, but they are not identical. I don't actually have a proper knob, so I'll make an attempt at cleaning this at some point. I also learned the earliest models. You can tell fairly quickly by looking at the knob. See, these are high knobs. Maybe this one's easier to see. The bump on it is fairly high. The oldest ones, this bump is much reduced. It's very small right at the bottom. So my guess on this, from all the research I've done, is that this is from around 1939, 1940, somewhere in that range. You know, I don't even know when Canada entered the war. But I would think probably the purchase was made after Canada entered the Second World War. I'll have to look that up too. And maybe I can find some information directly about the Canadian Experimental Establishment. Now, are we any closer to powering this thing up? Yeah, I think so. But first, coffee time. So I have acquired some documentation. I'm sure I'm going to acquire quite a bit while I work on this. So one of the things I picked up from someone, thank you very much to the person who did this, is this chart just on a big piece of paper so you can see it better. That's great. I have a schematic here on print, which of course I could put on the computer. We can look at more closely. It's a little hard to look at it in this scale, especially, Jim, you got it upside down. That might help. There's the plug, the power plug, which I guess is around the back of the radio right now. This is the antenna input, which is worth studying. I've already done that. And here's the output. I don't know if you can see that or not in my camera, but you have the plate circuit coming right out to the speaker connections. So, now, like I say, you would be using a 7,000 ohm speaker here. Have you got one? But this, of course, doesn't match what went on in this radio, because quite a bit has been done here to create these. And I have no information at all about this. Looking in the radio, your view is blocked quite a bit. But I would like to find this output transformer. I think the first thing for me to solve is to get some kind of output. Connection here, speaker, or perhaps into an amplifier or something like that. Well, I got to look for that transformer. Now, there is something. There is something in here. There's something right here, right there. It looks a little bit jammed in, and you notice the paint has come off it too. Now, what is that? That could be the Hammond output transformer. I'm going to stop for a minute and go look at another radio. See what it's got. Okay, so the other HRO I have, which looks pretty identical to this one, I mean they all look pretty identical, except it doesn't have these two connections. Has only one headphone jack on it. And when I look down here where I can see somewhat, very much looks like a transformer, there's nothing. It's just empty space right here. So that looks like what the Canadian experimental establishment did was they worked in this area of the radio. They fiddled around with this. They put the audio transformer right there. That caused them to move the terminals, the original terminals of the radio, a little further out to fit this transformer in, and when they did, they covered up the serial number, which is probably written here without the benefit of a letter. But I'll bet you I can find some information about from the Canadian point of view about this radio if I look, now that I know enough to look. By the way, the way I approach this stuff and an awful lot of things is an iterative approach, where I don't, look at the radio for a while, then read the information, then come back, look at the radio for a while, then read some more information. Every time you go back and forth, you pick up a little more knowledge and get a little better at it. So, got to start somewhere. The last video I started by looking at the radio, and as you know, as I've said, I've been reading a lot of stuff. So with the transformer there, 500 ohms here, you could probably plug an 8 ohm speaker in here and get something out of it, but that wouldn't be the best idea. That's a bit of a low impedance. And when you look at the transformer, so what's happening to it there? The paint is coming off. Paint coming off because it overheated? Probably not. Probably coming off because it just isn't good enough paint to survive. Unlike this coating. This coating is really rugged. Man. I'm going to have to plug something in there. I'm sure it's just a regular plug of this sort. And I think maybe what I'll set up is a range of 500 ohm load here, and then I'll tap off the load, across the load. I'll take a signal off and send it over to an amplifier, which I don't have, but I have ways, and maybe we'll try that. Okay, I think I've got a pretty good solution here. And this gigantic honking monster of a plug, but I've been able to put a 500 ohm resistor there. Nice and neat. It can go in there. Then we'll take this clip lead with a phono on the end. Clip it on. Make sure ground goes to ground. The set is not on, of course. I am nowhere near turning it on yet. do something like that. Get this clipped on here some relatively decent way. That's good. And I'll plug this in. When I plug this into here, it's going right into the sound system that you're listening to. Let me bring this around. And let's just check that. Now I have to put some my own headphones on here. And turn up. Let's say we're going to use the white one. Well, we'll use the red one. I like the red one better. Red one. Okay, so now I know which volume control is the red one. I'm not going to plug it in just yet. Because I should do some kind of, because we're a ways. I still have to put B+ on here. The actual next step is antenna into it. Yeah, we should do this with an antenna. So it's got a big PL259 type connector here, and I'm using the other type. No, I'm not. So I'm going to get a cable. It'll run from here to my antenna. Yeah, you might think going all the way to an antenna right off the bat is kind of extreme, but wouldn't it be cool if I can power this thing up and right away we hear signals? That would be the coolest thing. I give that like a 10% chance of success here. Okay, so we're now connected to an outdoor active antenna, particularly if I turn the antenna on down here. So that's the antenna. So that's the input, the output. Let's see, audio gain. This is the CW oscillator switched off. Selectivity should be pretty high. This is the B+ switch here. Right now it's off. So if I applied B+ to the set, it wouldn't make it to the tubes until you do that. Not a very good sounding switch. Doesn't sound good. This is the RF gain. Dirty as it might be, we should have it turned almost all the way up. Selectivity. I think straight up is probably a better starting spot. And the phasing control for the crystal that's in here, the 0 is an off. So in fact, I'm not sure this has any effect. At this time of day, we want to be at the high end of the band, the highest frequency in here, 14. We should be able to get stuff, and that'd be up around number 500. So up around this range. We're at the high end now. Okay, that's a little silly too, because I'm a long ways from doing that. The next step now is to arrange the 6.3 volts on the radio. Now, there's no on-off switch on this radio. This is just a B+ interrupting switch. So as soon as I hook this power up, it's going to start drawing current. And can I read the output? I'm looking up at my machine up there. I think I have to set up a meter to read the voltage. I think is what I really would want to read. Just the voltage. Oh, you know what? This will do it. If I flip this switch, no, it's reading the C. It's not reading this. No. We can't. I got to put a meter on this because I want to know for sure what this voltage is. Particularly if there's a short in here, it's going to draw it down. Okay, let me get all that set up here. Okay, I think it's time to really sort out this plug, and I have this wonderful diagram here, which is going to help big time down here. So we can see this will be the winding for operating the vacuum tubes, the heaters, and it's just going to the big pins, and that's not surprising. Big pins, big current, big pins. And then the little current high voltage is going to the other two pins. It would certainly look like the way this is held is just sticking out like this. Here's a diagram again up here. So So looking at this diagram, this pin is connected to the minus. Looking down here, turn it this way, and the minus pin, which they show is chassis grounded, also is also the same pin. Now, there's no numbers. Rectifier primary. Does not have switch. It doesn't matter. That's the best we can do. So now what happens if so I'm not going to get the big pins wrong. I don't think. I mean, it's AC anyway. So I'll bring down some 4 amps. That's a chunk of power. 4 amps. I think, as crazy as it is, I've got to use this. I've got to use one of my better leads here. I'm going to try to carry 4 amps. Hioki. Okay, and we'll go up here. And again, unfortunately, when I turn my power supply on, it's all going to be there. And these would go here. The high voltage part, it takes a while to show up when I turn that supply on, because there's a tube that has to heat up. But this part is going to be instant on. So as soon as I turn it on, whatever's going to happen is going to happen. Now I'm going to put these here. Okay, be smart. Disconnect one of these for now, and we'll just put it right on the meter. Right on the meter. Meter with no load. Okay, so this is voltage with no load. That's my stomach. Okay. So I have this on AC, and we think there's 6 volts. We'll put it on a 10 volt scale. So 6 volts on a 10 volt scale obviously is going to be up in this area. And nothing else hooked up to the supply. What do you say? It says perfect. So on this meter it's reading 6.8 volts, and that's good. We want a little extra voltage because I read that there's a voltage drop in the cord of about 0.3 volts. So you want to provide a little extra to it. But there we are. Very good. And, okay, I think that's good. Just double checking again. Power off. That's interesting. Is it really interesting? I don't know if it's interesting. So I have the switcher off, standby, and on. I put it in standby mode, and the heater voltage came up. So standby, it's sort of a half standby. It must be standby just for the high voltage output, which we're not using yet. So now I'm going to apply voltage to the set. Again, this is off right now. How will I know that I've achieved anything? Like, what's the set going to do? These are glass tubes and metal shells. So there's one tube here that's just glass. It may, without being a shield, if I pull one of these top shields off here. Oh, you can kind of look in. Might be able to see the heater in there. Watch for the heater in this one. Now, what if I'm overloading the thing? Well, what if it's too much current? I got to think about this. I read somewhere they have the requirements written somewhere. I'm gonna go. I'm gonna go 3 times. I started running around looking for where that information might be about the power supply requirements. And I thought, hey, just ask AI. We'll just ask Microsoft's AI system here, Copilot. So here's my question. What are the power requirements of an HRO receiver? And here's his answer. Classic high frequency communications. For AC operation, paired with a national type AB power unit delivers 230 volt at 75 milliamps, 6.3 volt at 3.1 amps. Good, that's within the range, the stated range of that supply. For battery operation, now this is not, mine is a 6 volt unit, so it's not a battery type. Alternate power supply, I don't know what that's all about. That looks like how to power the battery operated type. These specifications ensure the receiver operates efficiently and provides optimal performance. Are you planning to use or restore an HRO receiver? It's funny, but this system tries to get into conversation with you. At the end of everything I do with it, the AI system, the last thing is some question to continue the conversation. But no, I'm not going to continue it. There we are. So that's the answer I wanted right there. And I wish those things wouldn't come up. And 230 volts, 75 milliamps. And 75 milliamps is about 3/4 of the safe capacity of the DC part of my power supply. So good. This is good. Okay, green light. Okay, so I'm just getting ready to hit the switch there, and I realize, you know what, I can take an ohm meter and just read the resistance through the set and just make sure it's not 0, which is not likely. This is, I think, you know, I guess, did I say odds on whether this will work? I'd give it a 25% chance I can make this thing work as it is. That's what I think. Okay, so we're looking for a low resistance here. What are you? 1.3 ohms. Be as low as 1 ohm there. 1.1. So let's say 1 ohms because that's easy to calculate. If you put 6 volts into 1 ohm, you get 6 amps. But that's the cold resistance. So I think as soon as these things heat up, their resistance is going to go up. And I think we'll be just fine. How do I know if I'm overloading my supply? Wouldn't hurt to keep an eye on this voltage. So that's what I'm going to do. If the voltage drops to like 4 volts, then I can think, well, something's going wrong. And I can stop the experiment here. What would I expect it to read? About 6 volts, I think. I think there'll be a voltage drop in the cord I'm using. Okay, so this meter is going to read us the voltage. Okay, everything's ready to go. Well, how about we just take a step back? Everybody take a step back. And let me get something else here. And here it is. There we go. Keep this handy. No, I wouldn't. I'm not about to blow one. Okay, anyway, never mind all that. All these settings I already did. The B plus is off for whatever that's worth. This is the meter switch. It turns the meter on and off. It's off for whatever that's worth. Worth nothing. Yeah, I should be a little hesitant. Okay, that's enough hesitation. Now I gotta keep your eye on this meter. Here we go. It's slowly coming up as the tubes heat up. Like this light came on. This light came on. Ho, ho, ho. So this has come up, it's reading 5.5, and I heard a little tick. And that'd be expansion going on in the tubes. Very good indeed. Now, can we see any of this stuff lighting up? Let me, I have to turn off my shop lights here. And the only way is to unplug that big light up there. Okay, it's going to get dark in here. My shop door is open, so it won't get super dark. So yeah, that bright thing you're seeing there is a tube heater. And these other ones you not be able to see with this. Oh my gosh, it was not a good idea. Picking up a tripod in the middle of my shop in the dark. Not the best idea. Okay, let me put the lights. Well, let me look with my eyes here. Okay, 1, 2. These are all lighting. Well, maybe not all of them. As far as I can see, a good number of them are lighting. Okay, let me put some lights on again before some kind of disaster happens here. Okay. Yeah, that's good. And the voltage is holding up over here. Very good. Very, very good. Now, applying the high voltage. That's where we're at now. So I need to make the high voltage connections into this plug. So let's turn off the heaters here and drink some more coffee. That's a good idea. Okay, while I was drinking my coffee, I'm watching a video where a guy is talking about glacial erratics. If you live in a northern climate, you probably know exactly what I'm talking about. A glacial erratic is a weird boulder that's been carried by ice on a glacier or ice sheet and is deposited when the ice melts away, and there it sits. And people find these big boulders and go, what the heck is that doing here? What's a big chunk of granite doing here? There's no granite rock for 1,000 miles. What's this? So he's going around and showing these different huge boulders, house-sized boulders. Some of them are named and they're famous and they represent landmarks and towns and stuff like that. He's showing them in Europe and through the United States. He showed a couple in Canada. Glacial erratics. I mean, that's what I live among. They're all over my neighbor's property. I have one half buried in my backyard. The top of it is sticking out of the ground. Don't know how big that is. It could be that big. Could be the size of a car. I don't know. It's buried. There are erratics everywhere. My neighbor's front yard has a big one. It's sitting there. You can't move them. I mean, you need big equipment to take one of these things and move it. So during construction on that, they just get pushed aside. And if you go anywhere in southern Ontario, and I'm sure this is true in the northern United States too, where farmland has been cleared, and this is probably true in northern England and other parts of maybe through the Nordic countries, you want to clear land. You're removing, heavy rocks, 100-pound rocks by the hundreds. So it's kind of funny watching this show as he's showing a few rocks here and there and here and there, and I know that there's literally billions of these things all over the ground here in Canada. Yeah, that's right. In England, there's a whole thing about building rock walls. Those rock walls are generally built out of stone that has been transported by glaciers. Anyway, okay, enough of that stuff. I sort of built up the tension here. What are you going to do about this? So I got the high voltage hooked up now. High voltage brought down onto the plug. It's ready to go. The high voltage I can adjust. So meter set to 0 right now. This meter will show me the current draw by the radio. It should go straight up and no higher. If it goes straight up, when we get full voltage on it, it's a big thumbs up. Chances of this working, I don't know. Over here is the voltage. I can keep an eye on what the voltage is that I'm applying, the B+, and 200 is straight up. So maybe that's a good goal. Get this straight up, see what this current is. If it's straight up, we got an operating radio, except I haven't got it hooked up to the sound system just now, so I'm going to do that. Where's my arrangement here? Okay, this is I'm going to try to utilize the Hammond transformer. This has to go into here. Wasn't it the red one that I checked? No, let me put my headphones on again. What do we hear now? We shouldn't really hear anything. A hum? Yeah, this is the one. Just a hum. Let me make it not right channel. There we are. Both channels now. Okay, first step is heat up those tubes again. So now I'm going to turn this up a bit. So we'll be listening to whatever is happening. Whatever is happening. I'm going to throw the switch just to put on the heaters. Here we go. So you see the heater voltage going up. The lights are on. So surprised there's actually a light behind here. This meter, by the way, you can read the scale up to S9, and then it's as if there's nothing more there. There is. It's just so faded. There's a red part of the scale here, which is covering the signal strength above S9, so it switches into decibels here. So nothing is... That scared the heck out of me. You don't like being forgotten about, do you, meter? Hey, what about me? Okay, that certainly freaked me out. I expect a beep like that to come out of this guy. Okay, we're going to turn the volume down, just in case. And we're going to apply the high voltage. So again, I'm at the high end. I'm up around 14 megahertz. Just being hesitant. So this is off. So with this off, let's apply the high voltage. It shouldn't go in the radio and nothing should happen. Let's check that. Here we go. Okay, now when I flip this switch, there's always a little high voltage boom that goes into whatever it is I'm testing for some reason. Nothing happened whatsoever. Good. Okay, we're going to raise the voltage here. Watch this current. No current. Okay, so we got 200 volts, no current. Perfect. Down. Switch on. There might be a pop this time. Don't know if the switch works. Doesn't feel like it. Switch is on. This time the radio may actually come to life. Let's see what happens. Back up a little bit further. This is to give me a clear run to the door. if I have to run, I can make it out the door and trip over the camera. Here we go. Going up. You guys see no current flow. No current flow at all. Well, that's a little disappointing. My guess is this switch is pooched here. That's my guess. What else could it be? We are so close. The power is not even reaching the plug. Let's check that out. Let's bring back the BP meter. It's my Allen meter. And we will look for high voltage. So put this up on... That's on 1,000 volts. Okay, we're going to bring on some more. Bring on the DC. Oh, I actually left it on here. Let's turn it up a bit. Okay, it's like 100 volts or so. Can we find 100 volts down here? Without shorting anything. think I've got this connected wrong. Connected wrong, connected wrong. Whoop, 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 whoop. Yeah, I plugged this in incorrectly here. Duh. Okay, let's pull this out. Turn this down. Everybody calm down. Pull this out. Turn this off. Put this back in properly. Okay, this time's going to be a little different. First time was just a fake. It was a fake first timer. Gain volume, just in case that somehow has a big impact. Let's put this up to 2. Off. We'll test again. See that no current flows with the switch off. That's the idea. Okay, we're going on. And we're cranking up. No current. 200 volts, no current. Okay. Flip this on. As soon as I do, we might hear something. We might hear something. We heard nothing whatsoever. Still got the voltage here. We're going up. Here we go. This is the big test. No current. Zero current here. Okay, let's check for voltage. Take it back down to 100 and we'll check for voltage. I'm sure we're going to find it this time, because how many mistakes can I make? Really, I mean, there's a limit. There it is. I saw it. All of 70 volts there, even though the meter says almost 100. The fact that it's a negative doesn't matter. Okay, I think the situation is this switch isn't working. Let me make a big mistake here. Turn this off, turn that off. In fact, turn it right off. Turn off the heaters, turn off everything. I think that's the situation. This switch, it snaps this way, but this way it's. I think the switch is probably not working. And I also think that's it for today. That's as far as I'm going to get today. So I got through all the setup issues to make this operate, and I'm pretty happy with that. Solved all the problems. Input, output, power supply, whole thing. So all we got to do now is figure out how come no B plus getting in the radio, or so it appears. I mean, there could be other things. I threw that switch, the B plus went, and there's other problems, and that's why there's no current draw. But we have to start with this switch, I think. Here's one over here. Yeah, that's what a switch should sound like. Lovely. Yeah, it's got that doesn't work sound. Well, thanks a lot for watching, and yeah, it would have been more exciting if we got it going, but maybe tomorrow. Tomorrow I'll take a look at that switch, and we'll just pursue this problem of B plus not getting into the radio, and who knows, maybe we'll have it operating. Hope so. Have a great day. I'm off to do the same. See ya.